Hello and welcome to part 2 on this video series on Mongo Engine. So in this next video, we're going to take a look at the various query systems that we can use to get document out of Mongo Engine. Then we'll take a look at the meta property of the document class so that we can set special priority on our object. Then we'll see how we can use reference field to reference other object in other collection. Then we'll also take a look at the dynamic document class. That is another type of document that we can use in Mongo Engine. And lastly, we'll see how we can do document inheritance inside Mongo Engine. So let's get started. Okay, so now let's take a look at the query operation that we have to find some document in MongoDB with Mongo Engine. So to generate a lot of document, what I've done is first in this file, I've specified a user class with some properties. So a first name as a string field, last name. I made a string field for the gender with a choice of either female or male. I specify a name field for the age and a boolean field for the married status. So to generate a lot of data, what I've done, if I just went on this website, and here you can basically specify some priority that you want to generate some random values. So I've just selected first name, last name, age, gender, and marital status. Just selected 200, generate, and then you can save this to a text file. So I just saved that to a text file so that here I have some random user with some random info. So to fill our database, what I'm going to do is I've just made this quick function that will copy inside our file here along just under our class. So what I'm going to do is just open the text file, loop through all the line, and then I'm going to split all the line by the comma separation. And then I make a user instance of our class. And then I just specify all the field that have been split using the comma separation. And then I save the document. So we're going to run this. And if we go in our fxphd database, our collection user, here we have our 200 documents. So right now I'm just showing 50 at a time, but you can check all the document that we have here. So let's delete this since we've generated all the data that we needed. So let's start by seeing some default and basic query operations. So to find a document inside a collection, first you use we'll just make a variable called search equal, and then you use the class you want to search, and then you use the objects function, which you called. So right now, if we just do that and do a quick print search, and we'll just execute this file, you see that this search is returning all the user object that we have inside our collection. So now we could, for instance, do a quick loop in all the documents. So for you in search, let's say we want to print all the first names. So we'll do a quick print u.first name. So if we run this, we see that we have all the first name that we have inside our document. So that's currently returning all the document. So just to validate that, we can also use the count function of the query. So this will tell us how many document is returned by this object's query. So now if we run this, and of course, printed, so print search, that we see that we have our 200 document that has been returned. So now let's say that we want to actually, let's do a loop once again. So for you in search, and we'll print all the users. So we'll just remove the count. So that. So right now you see that we're printing all our user objects. So right now it's not telling us, it's not really telling us what we're seeing in terms of information and what the information of each user. So one very useful thing that we could do already with this class is to specify a string representation of the object. So by using the def str, the string representation, so like that, now we could return what we want instead of printing just the user object. So instead, what we can make our custom string. So let's say we want to return maybe, whoops, let's specify what we want as a string. So maybe user object, but then let's print and add some useful info so that we can see what is the info of the user. So maybe put a placeholder for the first name, a placeholder for the last name, and then maybe the age. So then we'll add the age as well. And let's say that that's what we want so far in terms of info. So then we'll just specify the variables. So we want first the first name, then the last name, and then the age. So self.age. So now if we run this once again, we see that instead of having just a user object printed, we have some info so that we can see actually will be more useful to see what the query is returning. So if we take a look at the result that we have here, we see that the objects are returned in the order that they were added in the database. So now what we could do is maybe specify the order in which we want the document to be returned. So let's say we want them to be returned by the age of the user. So here you could use the order by function. So order underscore by, and then you specify the property you want to sort the document. So let's say we want to sort them in ascending order by the age. So we'll use the age. So if we run this once again, you see that if I raise this, you see that all the documents are returned in order of the age. So you could also reverse this by just using the minus sign before the property. So now it should be in descending order. So from I to low. Other useful function you can use with the objects query. Maybe you want to get an average of all the user. So you could use the average function. So average, and you specify the properties. So we'll use the age. So now if we just print search, it should return an average of all the age that we have in all the document. So we'll run this. And the average age of all the documents, of all the property are 24 years old. So you can use the average. You can also use sum, which will give you the combination of all the returned document of the property age. So if we run this again, we see that that's the sum of all the ages that we have in the document. But now let's be a bit more specific in what we want to search, because right now we're always returning all the document. So what we could do is, let's say we want to stop the search as soon as we find one document. So by using first, this is going to return not a list of documents, but actually the first document that this query will match. So now if we run this, you see that we have just one document that is returned. So you can use the first function. You can also use index. So you could specify, let's say let's say you want a 10 first document. So from 0 to 10. So now if we print search, you see that we have 10 document returned. So if you only want the 2 first document, run this. And here you only have 1 document. You can also use the get function to only want, if you know that you're searching for a document that is unique in the database. So first we need to pass some keyword to the search. So let's just find one random document. So let's say this one. So let's say that we want to get this document by providing in the search some keyword that will make this search unique. So to provide some keyword, you just basically specify it here. So that age equal 22. So right now, if we print this search, you see that this is matching multiple document that has the age 22 in the user. So let's add the first name. So first name equal, and then Stewart, and print that. So we see now that we're only getting 1 document inside this list. So now instead we could use the get. So instead of returning a list of 1 document, this will return the actual document and will make the search much faster. So if we get this, you see now that we have this unique document. But make sure that you know that you're searching for a unique document, because else if we just, let's say we provide only the age right now and run this, we'll have an error that currently this is returning 19 items instead of 1. So we cannot use the get function on this. Okay, so before continuing with the option that we have to search document, let's take a look at also a special property of the document class that we can use to help us with some search option in our class. So you can use the meta attribute of the document class that will help you to set various options for your document. So for instance, here we could specify the order by default that we want the document to be returned. So we just saw that we can use the order by function of the object function, but we can also specify this by default in the meta attribute of this class. So to do that, we just specify this dictionary where we can pass some attribute. So to order a search result by default, you will use the ordering key. So ordering, and then you specify by which property you want the result to be sorted. So let's say we want it to be sorted by the first name. So we'll pass first name. And then if we do a quick search, so we'll search for all the documents. So we'll take our user class and use the objects function. And then we'll do a loop inside the search and we'll print all the document. So if we run this, we see that all the document by default were returned by the first name. So you could do that by the age like we did with the order by function. And also you could use the same operator like minus to reverse the search. So that's one useful way to sort your document by default. And one other thing that is very useful in the meta property is to build some indexes for your search. So that will make, if you know that, for instance, you will be searching a lot in this collection based on the first name. So you can build index inside MongoDB so that it will make a cache inside of it so that it will make this kind of search much faster when you'll be asking for the first name. So to do that, we'll add another key here. So indexes, and then you specify the index that you want to add inside MongoDB. So right now, if we take a look here in RoboTree, we see that we don't have any index, so we'll just specify one. So let's say we will be searching by the first name, so we'll add first name like that. We'll run this, and now if we go back here and refresh the collection and the index, we see that an index has been built inside MongoDB. So now when we'll be searching for the first name, MongoDB will be returning this much faster. Okay, so now let's get back to the query operation that we have inside MongoEngine. So let's rebuild a quick search. So search equal user.objects. So we'll just make a loop to see all the results that we'll be getting out of those various search. So for u in search, print u. Okay, so now we have everything. So if you're just wanting to make sure that you're matching one parameter like we just saw, we could use the age, for instance, equal 20. So now only document matching 20 years old will be returned. If you want to match two property, you can just tag them here like we saw. So if we want to make sure that we're only getting male, so we could say gender equal male. Run this again, and now we're only getting male that are 20 years old. But you can also use, let's say, we'll just delete this. Let's say we want to get people that the age is greater than 20 years old. So to add this, you just start with the property you want to search, and then you add 2_, and then that's where you put the operator you want to use. So if you want to get higher value than 20, you would use the greater than or equal. So greater than equal. If we run this, so only document higher than 20 years old are returned. Of course, you could use lower than or greater or equal. So here only under 20 years old is returned. You can also do some string search in here. So let's say that we want to search the first name property. So we'd use first name $_. And let's say we want to find all the name that start with A. So then you could use the start with like that, and then equal, and let's say all the name that start with A. So if we run this now, it's actually starts with. So run this again, and then we see that only those names are returned. So you can use this. You can also do a search inside a string. So let's say we want to get all the name that contains $N next one to another. So you could use the contains search function. So contains, and then you would put the string you want to search. Run this. Now you see that only those name has been returned. So you can also put some not operator before if you want to search for the exact opposite. So in this case, if you want all the name that do not contains $N, you would put not like that, and the not operator should be inside 2_ like that. So now if you run this, you see that only the name that does not match this has been returned. So by using you can pretty much use the not operator in front of any search to inverse the search that you're currently doing. So now you can make as complex as a search as you can. So let's say we want to make this a bit more complex. We could stack multiple criteria together. So let's do one last search. So for instance, objects, and let's say we want to have the age greater than 21 years old, and maybe again the age, but this time less than let's say 25. Then we could search for the last name, and let's say that we don't want it to contain any I in it, so last name not contains equal I. And let's just add the last one. Let's say that we don't want anyone that is married, so married equal false. So now if we print this here, you see that we have the result for this query. So of course there's a lot more option that we can use to search inside MongoDB with Mongo Engine. So you should, I highly recommend to check the documentation. There's a lot of parameter to search inside the database, but overall that's the kind of syntax that you'll be using to do various search inside Mongo Engine. Okay, so now let's take a look at something that is really powerful and really important inside Mongo Engine, which is the reference field that we can use in your document. So let's give a quick example of what I want to show you. So I'll just make a new class of shots, and we'll make this inherit from the document. And for now, we'll just specify two things. We'll specify a name for the shot, so name equal, and we'll make this a string field. And let's say we want to specify the project name of the shot so that we know that in which project this shot belongs to. So let's say project equal, and we'll make this a string field like that. So now I'll just make a quick loop so to generate 10 shot in our database. So for en range, and we'll just do a 10 loop. So we'll make shot equal shot, and for the name, we'll just name equal, and we'll just call this out of this loop number, so we'll pass the I, and let's z fill this so that we have some 0 before the number, so z fill, and let's put 4. So this will make 10 shot, and let's say that all those shots belong to the same project. So let's put also maybe shot dot project equal, and let's call test project, and then we'll just save this document. So shot.save. So now if we run this, go in our collection, just refresh, we have our shot. And if we expand a few documents, we see that we have the test project as our project name. But now what happens if for some reason the project changed name? You don't want to go back in all the document and change the project name. Instead, what you want to do is make a project collection where you create your project and then specify its name. And then inside the project, the shot document, what you want to do is a reference to this specific project document. So if you change the project name or any property out of the project, you only change it at one place, and this will be reflected in all the shot document. So let's implement this. So what I would do now is make a project class. So class project, and we'll make this out of document, and we'll put name equal, make a string field, and let's also add a different property that the shot doesn't have. So maybe client name equal, and we'll also make a string field for now. Okay, so now instead what you want to do when you'll be making your shot is you want to reference the project document. So instead of a string field, what you can use is a reference field that will reference to another type of document. So here as the property, you will specify the class that you want to reference. So here I would put the project. So this is going to be a project document here. So now let's actually delete those documents for now. So we'll just remove all document. Yes. So now we don't have any document. So first, let's save a project to the database. So we'll call project equal project. So we'll give this a name. So name, so actually name equal, and then let's call this my test project. And let's say that the client name is fxphd. So client name equal fxphd. And then we'll save this to the database. So now here in the project, we know we reference a project. So here when we'll be creating our shot, instead of passing a string, now we can pass a project object to this shot property. So for shot.project, instead we'll pass our project that we just created here. So project, and then we'll save it to the database. So let's run this once again. So now if we refresh all our collection, we have our project that is here with the two property that we've set. And inside here, we have our 10 shot. But here we see that in the project here, we have an object ID referencing to another document. So now if I go here and do a query on the shot, so we'll do search equal, we'll take our shot class, shot.objects. And for now, we'll just return all the document. So next, we'll do a quick loop. So for shot in search, print shot.name. So for now, we'll just print that. So we have our shot name. So now we can reference the project property. So we'll click, we'll put project. So now if we run this, you see that now this property is not returning a string, but it's returning the actual project that is referenced in the document. So now we could stack multiple property one after the other. So now we could say we want the project name. So project.name, run this, and we see that we have the project name of this project that is saved in the document. So you could say now you have access to also the client name and run this here. So you see you have this. So now if for some reason the client name, for instance, is changed inside this project, you don't have to go inside all the document to change the client name. Now you only have to go inside the project here and change the client name, and this then will be reflected inside all the shot. So let's do that. So let's find our project. So project equal, and we'll do a search on the project. So project, and let's find the name. So name equal my test project. So we'll just put that as a string like that. So now if we just print the project, we have our project object. So now what we can do is, since we have a reference to our project, we can reset the name. So project dot client name equal, let's just put another name. So let's say the Foundry, like that. Then we'll save our project. So project dot save. So now we're saving this to the database. So now after, if we print all the client name out of the shot, since we've changed back the name to another name inside this document, it should be reflected in all the shots. So if we run this, we see that something didn't work. So if we just go in the project, oh, we have multiple projects. Oh, that's because I haven't deleted this line here. So each time I was running the file, I was creating a new project. So we'll just redo that really quick. So we'll just delete all the project document here, and we'll just do a quick undo to recreate all the shots. So just do a loop again here. So we'll just create a project once and then do a loop and set the project for all the shot. So I just dropped the collection shot as well before. So run this. So if we refresh everything now, we have just a single project where our 10 shot with the project reference in it. So now I'll just make sure to delete this line so that we don't have the same kind of error again. So now let's redefine the project name as we were doing. So let's say now that inside our project, we'll be changing the name for instead of fxphd. So we'll just do a quick find of our project. So project equal projects dot objects. And since there's only one document, we can use the first function. So now if we print project, we should have our project here. So now we know that we can use this in our shot. So now we can loop in all the shot. So for shot in shot.objects, so we'll be looping in all the shot. And then let's print all the project name inside of it. So shot.project.name. So if we run this right now, we see that it's my test project. So let's say we want to change the name of the project. So here project.name equal new name, then we'll save our project. So now this time we should have a working solution where we've changed the name of the project, and since it's the same project object save in all the document, now when we'll be printing the name, we should have this new name printed. There you have it. Okay, so now let's take a look on how we can do queries using reference field. So here I've made a quick example of a user class, a project, and shot class. And in the project, we set just a property here to tell if the project is active or not, and as well as the name of the project. And the user, we just specify the name of a user. And in the shot, we have three properties. So a string field for the name of the shot, then a reference field based on who created who is assigned to the shot. So we pass a user document, and we also have a reference field for the project so that the shot is linked to a specific project. So here I've just made a quick bit of code to generate some data. So I've just made a list of 3 users that will save in our user collection. So here I do my first loop where I loop inside this list of 3 users. I make a new user document, specify the name of the user based on the loop, and then I save this document. Then I do the same thing for the project. So I just made a list of 5 projects, and inside this loop, I loop inside this list. I make a new project instance based on the name inside the loop. And then to specify if the project is active or not, I just imported the random module, and using a random choice, I've selected a random value based on true or false to set the active project. So this will be set randomly, and then I save the project. And here inside, just before creating all the shot, I just make a variable call and on the user object query. So this return all our user. So Hugo, John, and Bob. And then once we have those 3 objects, we start a for I in range loop of 50 shot, and then we'll just make a new shot object based on the name of the loop. So 1, 2, 3, 4, 5 to 50. And then I'll just z-fill the number so that we have a couple of 0 before the digit. Then for the shot, I set the project. So since we're in the loop project, I will create 50 shots for each project. So at each project loop, we'll set the project. And then we also select a random user based on this query here. So this is returning our 3 object, and then using the random choice, we're just selecting a random user in the list of user, and then we save this to the database. So basically this will give us a list of 50 shots on each of the project, and each of the shot will have a random assigned user to it, and also the project are randomly set active or not. So we'll just run this and just refresh our collection. So here we have our 3 collections. So we have our 3 user, then we have our project. So we have our 5 projects. So they should have a random value in the active priority. So this one is active, this one is false, 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 and true. And then we have our shot. So we have a lot of shot. Actually, we should have over 250 shots, so 50 shots per project. And each of those shots has a project reference to it, assigned user reference to it, and our shot number. So now we can just comment that, since we won't be using that anymore since we've generated the data. So now let's say that we want to find all the shots that are assigned to, let's say, Bob, and not only that are assigned to Bob, but also that the project is still active in the database. So we don't want to get shot in a project that is not active. So to do this kind of query, we have to do it in multiple steps, because we cannot do that in a single query, because we cannot, when using reference field, we have to split the query in multiple parts. So first we want to get a query to get our user. So in this case, Bob. So we'll make a new variable called user equal, and then we'll do a query on our user document. So we'll take the user dot objects like that, and then we want to find our Bob user. So name equal Bob like that, and we'll use the get function to get just directly the single document. So right now, this, if we just print the user dot name, we should have our Bob user. So first thing is done. Next, we want to get all the active projects. So projects equal, then we'll take our project class, then we'll use the objects method to do a query, And then we want to get only the active project. So active equal true, like that. So now if we print project, we have our two projects that if we go here in our collection and expand them all, so here we see that we have two active projects. So that's those two projects here. And then we have to do our final query that will use those two results here inside our shot query that we're going to do. So now we'll do our shots equal, and then we'll take our shot class and use the objects method to do the query. So now we want to pass our user. So we will pass the assigned user. So we want to find this here. So assign user equal, and then we'll pass this user result that we have here. So this is the reference field that we pass here. So this is the assigned user we want to find. And then we only want shots that are inside an active project. So we'll pass our project priority that we want to query here. So we'll do project equal, and then we want to get what we've got from this second query. So project equal project. But since this is actually a list of project object, we cannot use the equal sign. So what we want to do instead is to check if the project is inside a list. So to do that, we'll use the in operator. So we'll put the 2_ and pass the in like that. So now this is telling us to look if the project that is currently in this shot object is also in the list of this project returned from this query here. So like that. So now if we run this code, we don't have any error. So we'll just do a quick loop. So let's say for I in shots. And just to validate that we are having our Bob user returned. So we'll do print I dot assigned user dot name. So let's run this. So we see that all the shots belong to Bob. And let's also print the active property of the project. So I dot project dot active. So see that all the project are also marked as being active. So using this multiple step query, that's what we need to do, use a multiple step query to get the document that we want to pass inside the query of other class that are using reference field as some property. And now the cool thing is that you can access all those properties just from one single document with nested property. So just to give you an example here, I've made a class for the user, one for the project, one for a sequence, and one for a shot. So here I've just made a user object and save it to the database. Then I create a new project, and in this project class, I specify who created the project. So I made a reference field for the user, and then I pass my user object. And then we make a sequence, and in the sequence, we make a reference to the project. And lastly, we make a new shot, and in this shot, we have a reference field for the sequence. And then I save that in the database as well. So we just run this. So now if we open the database, we have a collection for all of those class. So now I'll just comment that, and I'll just get the shot we've created. So I'll make shot equal shot.objects. And since we only have one shot, I'll just use the first function. And now if we print shot like that, we have our shot object. But now, since I'm using all those reference fields, I can use nested property to get some property of other class. So for example, we could use, let's say we want to know who created this project. So we could use the shot, and then we want to get a reference to the sequence. So then sequence. Then we want to, from this sequence object, we want to get the project. So project. And then we want to know who created this project. So we'll get the creator property. So creator. And then we want to print the name of this user. So now we can use the name property. So if we run this, we see that we get the name of the user that was specified in all those nested reference field. So you see how powerful this is when nesting multiple property in reference document in those class. You can stack all those property one after the other to get to the root document specified in the reference field. And now also the cool thing is that you can make your own custom property to do some shortcut. For example, let's say that we want to get the project attached to the shot. So right now you're using the sequence property, that inside the sequence property we have the project, but now we can make our custom property to directly go to the project. So for example, here what we would do in the shot, we would make our own property. So we'll just make the property decorator like that. Then we'll make our function. So we would call this project like this. So now to go directly to the project without passing to the sequence here, what you could do is use self, which is currently the current shot, then sequence. So we're taking the sequence reference field here, and then we want to get the project like that, and we want to return that. So now this custom property here is returning directly the project attached to this sequence property from the shot. So now here, once we get this shot object, what you could use instead of calling the sequence property and then the project property of this nested reference field, you can directly call your project property. So project. And since this property that we've made here is returning the project attached to this sequence, we should get the same project that this would return. So we'll just run this, and we have our project object. So now you see that by adding your own custom property, you can also shortcut some reference field from your class and go directly to another object nested in the reference field. So now let's see how we can delete a document in MongoDB with my Mongo engine. So here I have still my one project with my 10 shot with the project reference here as a reference field. So now what you can do, if let's say I just want to delete a single shot, so we'll just do a quick search equal shot.object. And let's find just a single shot. So name equal, and let's take this shot here. So 0008. So this should be returning just a single document. So we'll run this. We have this document. So now we can just use the delete function like that. So we'll run this. Just need to run this, not print it. So we'll just run this. And if we update our shot collection, we see that now shot number 8 has been deleted. So obviously, this is not something you really want to do when doing database, unless you're really sure you don't want to delete document. Maybe you'll more likely to want to use something like an active boolean to specify if the document is still active. But still, if you want to delete a document, that's how you can do it. And one important thing when using reference document inside Mongo Engine is that you can specify that if you delete, for instance, the project that is referenced in all the shot, if you delete this project, then if we get a shot and print, for instance, the project name, this will throw an error because the original project will no longer be inside the database. So the reference inside here won't be valid anymore. So one thing you can specify inside the field here is the reference field is you can specify that if you ever delete the original document, all the documents that are referencing to this document will be deleted as well. So to do that, you would do that inside the reference field. You would use another keyword. So you would use the reverse delete rule equal. And then if you want to tell that it need to delete all the document that reference to this original document, you want to use the cascade property. So cascade like that. So now if let's say we find this project, so project equal project dot object, and since there's only one project, we can use the first. So now if we print the project just to make sure we get this project, so we have this project here. So now if we delete this project, what will happen is all the shot that are referencing to this project will be deleted. So for instance, let's just to see, I'll modify one of the projects. So I'll just edit this document. And for the project ID here, I'll just edit the ID so that it's not referencing to the project we're going to delete. And we'll save this. Oh, I just need to keep the same number of digits. So I'll just put a random one. So like that, and click save. So now if I take my project and delete it, use the delete function. So now what I expect to happen is all the shots will be deleted that are linked to this project, except the one I just edited so that it's not linked to the same project. So now we can run this. And if we go in, we do a quick refresh of our collection inside the project, we don't have any project anymore because we've deleted the project. And if we go in the shot collection here, just close all those tabs like that and expand that. So going back in the shot here, all the shot reference to this project has been deleted. So that's one way to make sure that you don't have broken connection in your document. You can just use the reverse delete rule to specify to delete the original document reference in a reference field. Another cool thing you can do with document class is to inherit a class from another type of document, so that if two classes of document are sharing the same kind of property, but the other class has some custom property just unique to this class, you can start from another class, use all the property, and just add the custom property to this class. So let's make again a shot class document. So we're inherit from document, and this one will have a name, so a string field. Then let's maybe just add the resolution. So width equal int field, and height int field as well. So that would be our base document class for the shot. And then let's say that we want to make another kind of shot, maybe some stereo shot. that will share all those fields, but will have a custom field just unique to our stereo shot. So what you would do is then make your other class. So class, and we'll call this one stereo shot. So stereo shot. And then instead of inheriting from the document class, what we'll do is inherit from our base shot class here. So we'll pass our shot like that. So then we would add the field unique just for this stereo shot document. So let's call this one is stereo equal, and let's make this a Boolean field like that. So this will return if actually let's call this one more. We know it's stereo shot, maybe more some is it a conversion? So conversion. So what this will tell us if this stereo shot is a native stereo shot or maybe it's made as a conversion. So just do that. And then the thing is that we need to specify that this shot can be inherited in this class here. So again, we gotta use the meta property of the document to specify that we allow inheritance for this document. So inside the one we want to pass to this other class, what we'll call our meta property, and then we'll just specify the allow inheritance property. So allow inheritance, and we want to specify that we allow inheritance for this class. So we'll pass true like that. So now if we take our, let's make one instance of a stereo shot. So stereo shot equal this, and now we can pass the name since we're inheriting this property here. So that's one property that we can use. So name equal, let's just call this one test like that. And then we can also specify this field here that is just specified in our stereo class. So is stereo equal true, actually is conversion. So conversion true, and then we'll save this. And actually let's make also just a simple shot to see the difference. So shot equal shot, and let's call this one test shot, and we'll just pass this property, and we'll save this document as well. So now we're saving one shot document and also a stereo shot document here inherited by the base shot class here. So we'll save both documents. So we'll just run this. And now if we go in our collection, you see that we only have the base shot specified as a collection. But if we open both documents, you see that the one that is a stereo shot, we see that we have this special property here that specified that this is inherited by the shot. And we also have this specific property here added in the shot that specify also the class. So in this one, we see the inheritance between the shot and the stereo shot. And here, since this is the root base class, you see that we only have the shot class specified here. So this special property added here, because we've added this allow inheritance meta here, then this add this special property that will make the difference between a normal shot and a stereo shot inherited by the base class shot. So as you can see, this can get pretty handy because you don't have to duplicate the class for field that are shared among two type of class that are kind of the same. So you can just make a root class and then make other class based on this root class that will be shared, will be sharing property among all those class. Okay, so far everything that we've been using to make some class is based on the document object of Mongo Engine. But there's other type of document that you can use along with Mongo Engine. Because right now when you're using the document, you have to make the schema inside the class, and then you have to respect what you have defined inside the document. But sometimes maybe you want something a bit more flexible, and that you want to, depending of the very specific document inside MongoDB, you want to maybe add a property just to a single document. So by using the document here, you're not able to do that because you have to respect every property that you set inside the document. But there's other type of document that you can use that will allow you to do that. So with Mongo Engine, we have it's called a dynamic document that will pretty much be the same thing as the document, but will give you a bit more flexibility in terms of property. So let's just make a shot based on dynamic document. So we'll just give a name for now, and we'll just make an instance. So shot equal shot. And then we'll pass a name. So just set the property, and then we'll save this. Just run this and go inside our database collection. And here we have our object. So now we'll just query this document. So shot equal shot dot objects. And since there's only one document, we'll just take the first result. So if we just print shot, we should have our document. So now let's say that you want to add the first frame property, even though it's not defined here. So now you could take your shot object and take first frame as the name of the property equal 1, and then save this document once again, run this. Now if we refresh this, go in our document, we see that we have a first frame property set here, even though we haven't defined any property for this type of document. So now we could make a completely different document. So shot equal, take the class once again and call this one test2. Name equal test2, and directly inside the class creation we could define other property. So let's do it here. So last frame equal 100, and maybe something called, let's call aspect ratio equal 2, and save this. Let's refresh our collection. So see now that you have two documents with completely different property. So using the dynamic document will give you this kind of flexibility. So depending of what you want to save in the database, sometimes you'll want to use dynamic document for, let's say you're making a class for your software that you're using in your pipeline, and depending on the software, you'll have different property for each software. So depending of the software, you'll set maybe the property that is not valid, let's say inside for Maya, that is not valid for Nuke. So each document would have completely different properties. So you would have this flexibility to add property on the fly with the dynamic document of Mongo Engine. But beside that, they're all using the same kind of function of the document in terms of query and stuff like that. The main difference between the dynamic and the normal document basically is the flexibility in terms of property that you can add inside each document. Let's now take a look on how we can optimize the way we save document in the Mongo Engine database. So we'll just make a quick class called test. Make this document and just set a quick property. So name equal string field like that. And we'll just save one document. So we'll just make t equal test and set the name. So name equal test dot save. So run this. So we just refresh once again. Collection test. So we have our single document. So that was pretty fast. But let's say that you're creating a lot of document all at once. So just to time the time that it takes to save document in the database, we'll just import the time module so that we can time our insert in the database. So here I'll just do a timestamp. So let's call before equal time.time. So this was going to make a timestamp before our action of saving the document. So now we're just going to do a quick loop and create a lot of document all at once. So for I in range, and let's make 20,000 documents. So 20,000 loop. So here we'll make an instance of the document and save it in the database. And once all those 20,000 document will be saved, we'll just print time.time minus our before variable that is our timestamp before the loop. So this will tell us how long it took to save all those documents in the database. Let's just run this. So we'll give it some time. So now it's basically what it's currently doing is making an instance of the class, and each time sending the document in MongoDB and then doing another loop and storing all those documents one after the other. So to save 20,000 documents, it took about 8 seconds to save all those documents in the collection. So depending also of the amount of property and data you have in each document, this is also vary the time to save the document. But already you see that it took 8 seconds to just save a simple document with one property. So there's a way to optimize the save option like that, because right now it's doing 20,000 operation inside MongoDB because everything is done one after the other. So now instead of doing it this way, what we could do is do a list. So we'll just make a variable called L equal list. So we'll just make an empty list, and we'll also drop this collection for now. So drop collection, yes. So instead, what we'll be doing, instead of saving the document all after one the other, so we'll remove the save. So we'll just make an instance here, but instead of saving it, we'll append it to our Python list. So l.append, and we'll append the document. And then what we'll do, instead of using the save function on the document, we'll take our collection, our class here, our test class, so test, and we'll use the objects method, so objects. And with the objects, we can do an insert, and inside this insert call, we'll pass the list of all the documents that we want to save all at once. So we'll pass our L list. So now instead of saving one after the other, we're just filling the list, the Python list, and then we'll do one transaction with MongoDB to store all those documents in the database. So doing one after the other took 8 seconds. So let's compare the time it will take to do it this way. So we'll just run this once again. And instead of taking 8 seconds, it only took 2 seconds to save the same amount of document. So if you're creating multiple documents all at once, make sure to use the insert function to only do the minimum required transaction that you have to do with MongoDB to save the document. Because right now we're saving everything locally on this computer, so even if we're saving all the document one after the other, it's still pretty fast. But this is going to be even more important if your MongoDB database is somewhere on another computer, or even worse, on the cloud. So making the minimum of transaction as possible will make sure that your workflow when dealing with a database will be as fast as possible. So that concludes our overview of Mongo Engine. So I hope you enjoyed this one. So this is going to be the system that we're going to use in all the future training of this series. So we'll be building everything on top of Mongo Engine.